OW2con'12 ended 4 months ago in July and was judged by the European Commission as an excellent project in terms of results. The infrastructure and the support to the software will be given by the partners until 1 year more, until June 2013. So you still have some time to get the results and interact with the programmers and the developers. OW2con' was about allowing the scientists, the so-called long-tail scientists, those that doesn't have access to big computing resources like physicists at CERN or biochemistry at EMBL, in order to develop short-term or one-shot experiments and analysis over their data. And we developed a platform for the scientists in collaboration with Microsoft and the Azure team, and we allowed the scientists' application to run seamlessly on an Open Nebula-based infrastructure and Microsoft Azure. We have developed a set of platform-level APIs in order to make more easy the development and deployment of the application in a cloud environment. We have based, in order to interact with the infrastructure layer, we have based our system on the OCCI interfaces, extending them in order to have the OVF messages as part of the OCCI APIs. During the project, it was a 2 years project. After 1 year, we already had a beta version on which we had some internal testing made by 7 scenarios, 7 partners that provide the 7 different scenarios. And we launched an open call. An open call for other scientists that could use the infrastructure and the platform in order to provide extra requirement and being a sort of beta testers of the platform. So after 2 years of projects and 24, 25 different applications running over this platform, I can say that this was a very nice result and consolidated set of components. So as I said before, our objective was to sit on top of infrastructure as a service and platform in order to provide a set of services that can allow a seamless integration of different platform and infrastructure as a service layers. In terms of community, in OW2con', we got a very huge number of different scientific domains. And as I said before, this instrument, this option for using an open calls allowed a very huge participation from people external to the project that didn't participate to the conceptual phase of the project and provide extra requirement and extra support. So in terms of conceptual architecture, what we have developed is a set of components that could allow the deployment of different programming models. We developed 2 different sets of programming models, one based on parallel programming and one based on batch of jobs, that can be instantiated into the execution environment, and a set of management data interfaces based on CDMI standards in order to allow the application and the programming model enactment component in order to extract and store the data in the storage services provided by these infrastructures or platforms. In terms of components, here you can see where we use the different standards, the resource usage in terms of as part of the accounting and billing system, the base in terms of the programming model enactment, OCCI, and SNIA CDMI. These were the components that we have developed and how this can be used in order to deploy and run the application. All the releases are open sources and have been released under the project Forge, and are released under Apache 2.0, so including the component developed by the Microsoft guys from the European Microsoft Innovation Center. There were different type of usages that you can that the users did. They used it to provide high throughput computing, to follow data, to have a data flow of different jobs, and coordinate different jobs at different fine-grained details, in particular for biochemistry computation. These were some examples of the scenarios that we have supported during the last year, the second year, and we can say that it was quite successful. Some of the scenarios have been engaged with some of the partners in order to continue also on commercial basis their application. These again are a couple of examples: the earthquake propagation simulation done by the University of the Aristotle University of Thessaloniki. There was a virtual docking computation for in silico computation for drug design, and there was some analysis of radiotherapy planning. So in terms of benefits, there was in the interesting speed up in the performance using the Venus platform with respect other direct access to the other to other clouds, and there was the interesting feedback from 4 of the pilots, as I said before, that conceived a business application based on the exercise done within the platform. So, as a result, it was an interesting exercise. The scientists are facing with requirements that you cannot find in the usual market, in the usual business. So it is interesting because they can pave the way for future application and for future use of the clouds. So in that sense, it was very interesting to work with them. Most of the scientific applications have been implemented and revealed some interesting business scenarios, and we will see in the next months or years what will come from that. So thank you very much. Thank you again to the organizers.